Okay, so in front of us we have a GTX 1080 Ti. This is the SC2 by EVGA. So this card was sent to me by a customer who asked that I repair it for them. So anyways, like all the broken cards that we get, we want to first start by checking for a short on the base voltage rails. And then we want to take a resistance measurement of the voltage rails generated by the card itself. So starting with, let's see, we're going to start with 12 volts. So at the PCI Express slot, we can find both 12 volts and 3.3 volts. So if you don't know, the first 3 pins are 12 volts. And we're perfectly good. To find 3.3 volts, we start at this notch and we go 4 pins left. Again, perfectly good. Okay, so now we want to check 12 volts at both the 6 pin and the 8 pin. To check the 6 pin, we can check this inductor here. Again, perfectly fine. And to check the 8 pin, we can check this inductor here. Again, perfectly fine. So now we want to go over to resistance mode and check the resistances of the voltage rails generated by the card itself. Okay, so if you don't know, the first voltage rail to turn on is 5 volts. So typically at 5 volts, we expect to see about 1.3 kilo ohms. 1.285, close enough. That's good. Now at 1.8 volts, we should see about 850 ohms. So this is normal resistance for a 1080 Ti, and I should say a near reference 1080 Ti. And unfortunately, we have 132 ohms. So in my experience, a relatively low resistance or abnormally low resistance on 1.8 volts is accompanied by a dead core well over 95% of the time, and 132 ohms is definitely kind of worrying. Okay, so anyways, by the way, if you don't know, you can expect to see either 750 or 650 on Asus or say Palette and PNY cards, and that's still perfectly normal. Now we want to check the PEX rail. So typically for the PEX rail, I hope to see something above 40, and we have 6 ohms. Again, this is actually kind of bad. So in my experience, a abnormally low resistance on the PEX rail is accompanied by a dead core well over 95% of the time, and right now we have an abnormally low resistance on both 1 volt and 1.8 volts. Now finally, let's check the memory phase, though there's not that much point at this point anymore. But anyways, I expect to see about 75 ohms typically for a near reference 1080 Ti, and we have 53 ohms, which again is kind of low. Okay, so we have the entire trifecta. We have low resistance on the PEX rail, low resistance on 1.8 volts, and low resistance on the memory. So any one of these alone would imply a dead core most of the time, except for maybe not the memory, but at least on 1.8 volts, and the PEX. But this has all three. So at this point, I dare say it's as simple as we have a dead core. However, I am kind of curious. Since we don't have a short on 12 volts, and typically sometimes these cores, they do just die, but usually when they just die, they only go short on one major voltage rail, and not all three connected to the core at least. So anyways, I'm going to dig around on this card a little more. I think I actually know what's wrong or what's happened, but I need to confirm it off camera. Okay, in order to determine what's wrong with our card, we're going to use a PCIe tester, or at least that's what I call it. So this is like the name implies, a PCIe testing tool. This thing's job is to test the data integrity and the not signal integrity, but rather just basically check the PCIe data lanes to see if there's anything wrong. So I should note that before you go out and buy this tool, which I do recommend, by the way, if you fix graphics cards on a regular basis, I should note that this tool is a little bit dangerous in a sense. So I have my 24 volt laptop adapter here. I just want to note something before you go out and buy this tool. You'll notice that as I plug it in, and by the way, the AC adapter is turned on. As you plug it in, as you can see, there are sparks. So one more time, just for, just so you can see it again, it's sparks. So I just want to be clear, in case you work on, let's say, a gasoline covered table. But anyways, okay. So the way you use this is you plug in your the card that you want to test. So I have the same 1080 Ti. So I'm just going to plug it in momentarily on camera. Any PCIe slot will do. And then I'm going to plug in the AC adapter. This is the part where I recommend you turn on your AC adapter instead of just leaving it on like I do. And by the way, I'm using 24 volts, but I think you can actually use something lower, and if you can, I would recommend something lower. So the way it works is that you then click this button here, and then you're supposed to pay attention to the, you notice how there's all these red LEDs. Well, if we go over the red LEDs, the way it works on a working card is that all of these LEDs are supposed to turn on, and in particular, they're supposed to all be of equal brightness. But as you can kind of see on camera, I'm not too sure how good the focus is, but we have a problem with one particular data lane. So this is marked HSIN1. I should know that this is a misprint. It actually should say HSIN0. So this suggests to us that we have a problem with our HSIN0 on, which is one of our PCIe data lanes. Now I want to note that this particular PCIe checker is a little bit flawed, as in it can sometimes give you a reading that says everything is good when there's something wrong. In particular, one thing that this checker can't do is verify the capacitor ratings of the the capacitance of the PCIe capacitors on the back. So these capacitors are supposed to be 220 nanofarad, but the checker cannot determine what the nanofarad rating is, only that they're there. Anyways, let's go ahead and unplug the card and determine which, let's take the power off first. So now let's go ahead and determine which lane is HSIN1. HSIN0. Okay, so just for firstly, okay, there's four letters and a number. So the first two letters are HS. HS just refers to high speed. This doesn't matter in the decoding. So then the next letter is either I or O. If it's O, then your problem data lane is on the back here. So, but if it's I, it's on the front. So I corresponds to inputs and O corresponds to outputs. So hold on, let me refocus the camera. Okay, like I was saying, I corresponds to input. So yeah, that's right, inputs. Now the N portion corresponds to the negative. So the negative is the first in these data pairs for the PCIe lanes. Then there are 16 pairs, by the way, corresponding to 16 lanes of bandwidth. In these data pairs, N refers to the first data pair. So the first data lane in a pair, while P refers to the second data lane. Now, as you may remember, we have a problem with HSIN0. So the way the numbering works, at least on the front, is 0 is the first data pair and 15 is the last and 16th data pair here. So since we have a problem with HSIN0, we can deduce we have a problem with the first data pin on the first data pair. So let's now we want to confirm this. So we're going to get our multimeter and we're going to put it in diode mode. This is the standard way of checking a data line and the integrity of the data line. Okay, so probe on ground. Now, let's go ahead and check HSIN0. So the actual reading itself doesn't matter. What matters is that the readings themselves across all data lanes, the reading does matter, of course. You don't want 0 in open line, but the exact numbering itself doesn't matter because it varies meter to meter. What really matters is that they're all the same. So we're going to check the first data pin on the first pair, 2.89, but on the second data pin for the first pair, 0.5. So we have a difference, which is not good. So if we go to any random data pin on any random pair, you'll see that we have 0.5, and going to another data pin, 0.5. Okay, so on my multimeter on a working card, working 1080 Ti, I would get 0.5 volts on a diode mode if I check the actual PCIe lanes. But on that first pin, we have 2.89 volts. So I can tell you exactly why we have 2.89 volts. We have 2.89 volts because very, very likely what's happened is that one of the previous owners was mining on this card, and then they had this card inserted into a mining riser, where the mining riser was then inserted backwards into the motherboard. So let's go ahead and analyze exactly what this looks like when you insert, let's say, a mining riser backwards into a motherboard. Okay, so as you saw in the last clip, my impression is that what's happened is that the owner, or one of the previous owners, has inserted this card they inserted this card into a mining riser and then inserted the mining riser backwards. I was originally going to do like some diagram, showing which pins end up mapping to which, but I think it's best if I actually just show you. So I have I should note that the damage that is incurred by a mining riser being inserted backwards depends on the riser itself, but I'm just going to use a standard mining riser, as you can see here. This is with a USB X1 adapter. So anyways, like I said, rather than do some diagram with a pinout, I'm just going to show you. So instead of inserting it normally, I'm going to insert it backwards. And then I'm going to boot the motherboard, and now let's see, let's just take a voltage reading of our data pins. Okay, so as you saw, I inserted the mining riser backwards into my motherboard. Now let's go ahead and examine the voltage at the first data pin of our first PCIe lane, the first data pair, I should say. So, as you can see, we have 3.2 volts. So if you can't tell, this is, like I said, the first data pin and data pair, and that because we have 3.2 volts, we also have a 3.2 volts sent directly to the core. So despite the fact that this is one particular model of a mining riser, this is actually rather common. You know, even across other types of mining risers, when they're inserted backwards into the motherboard, 3.2 volts is sent directly to the GPU itself through the first PCIe lane, which is, by the way, the third pin going right from this notch. So like I said, 3.2 volts is sent down to the GPU itself, and that by extension, the GPU often dies. Now I say often because in some cases the GPU does live, but usually the GPUs that do live, that first data line is completely fried and is non-usable, and the only way you can use the card is by inserting it into an old AMD motherboard with a better I'm not sure exactly what they do, but I think it's like PCIe lane switching or bifurcation. But like I said, they sometimes are compatible with old AMD motherboards, but not modern Intel motherboards. So anyways, it goes without saying that you know, if you have a mining riser, be careful and don't insert them backwards, otherwise you end up with a dead core. Anyways, I apologize in advance if this video seems a little drawn out. It's a rather important topic, especially today, and I've been meaning to cover it for a while. So I hope you learned something watching this video, and hopefully I'll see you in the next one.